All right, welcome back. This is Check for Understanding number 3. I just realized for Check for Understandings numbers 1 and 2, I did not do the domain and range. So make sure you do that for those first two and just check your answer with the book. Hopefully I don't forget with this one. So this is a graph of f of x, and you're to transform it according to this rule. 4 times f at negative half x. Okay, so our poster. A is the 4, and B is the negative 1/2. B has two things that are happening here. There's the negative, and there is the half. You should remember that B being negative is a horizontal reflection, and the half, B's bad, is a horizontal, does the opposite, stretch by 1/2. So this is a stretch by 1/2. So we definitely should write these rules out for this one, since there's lots going on. Okay, so find room to write this. Here it goes. The 4. The 4 is a vertical stretch by, you guessed it, 4. The negative 1/2, well, we'll count that as negative 1 first. Negative 1, that's a horizontal reflection over, you guessed it, y-axis. And then a half, 0.5, is a horizontal, B's bad, stretch by 1/2. 1/2, which is 2. Okay. I'm going to do, because this question has a lot going on, I'm going to do 3 tables for the 3 changes. Those of you that really are on top of this stuff, feel free just to do the 1 table, okay? But I'm going to do 2. And I'm the teacher, so I'm allowed to do that. So let's pick some original points on the original graph in green. X and Y. X is negative 2 and Y is 0. I'm going to put an arrow on this bending ray. Another point. You see over here at negative 1, we have 1. Negative 1, 1. We have another point here that's right on the corner of a grid. That's the point 2, 2. And then up here, let's go to 7. We have 7, 3. Okay, that's f of x. Let's make a change. Notice that there are 2 horizontal effects. I'll put a star beside the 2 horizontal changes. And there's 1 vertical change. I'll put a triangle over here beside the vertical change. I will do the vertical change first. The 4f of x part. 4f at x. Vertical stretch by 4. Y affects the stretches vertically. So y must be multiplied by 4. So I'm going to take the 0, multiply it by 4, and I get 0. I'll take this 1, multiply it by 4, I get 4. I'll take the 2 and multiply it by 4, and I get 8. And the 3 times 4 is 12. And get rid of those arrows. You know what I'm talking about, hopefully. And because I'm doing 1 transformation at a time, I'm going to leave the x values alone until I get to the next table. The next table, I'm going to do the horizontal effects. Now remember what I said from Thursday's class. You stretch before you shift. But here, we're stretching and kind of reflecting. We could do those at the same time because notice it's negative 0.5, which is negative 1/2. If you're multiplying the x values by negative 1, multiply x by negative 1 for the reflection, and then you're multiplying x again for the stretch by the reciprocal of 1/2 by 2, I'm writing this down over here. Couldn't you just put it all together and say that you're multiplying x by -2? That's the same thing, right? So that's what we'll do here. Okay? So I'm going to write down in blue, I'm going to include the 4f at x, which we've already done, but now I'm going to include a negative 0.5x transformation. So here we go, x, y. The y values I've already determined, 0, 4, 8, and 12. The x values, I'm multiplying x by -1 and by 2, which is multiplying x by -2. So -2 times -2, you guessed it, 4. -2 times -1, +2. 2 times -2, -4. And 7 times -2 is -14. We now need to plot those values. Okay, so I've got my grid now, and I need to plot those values. So I plotted 4, 0 here, +2, 4 here, -4, 8 here, and -14, 12 falls off the grid, but I've got enough room. I'll put it over here. Notice this is a bending ray that originally went over here to the right. Since this was a horizontal reflection, it must go to the left. So I know that it goes this way. I connect it with a smooth curve. I put my arrow on the end and just step back and look at it now. Does this graph look like it's been stretched vertically by 4? Definitely. Y is 4 times what it used to be. Does it look like it's been horizontally reflected? Definitely. It now goes to the left. Does it look like it's been horizontally stretched by 2? Definitely. If you look at a couple of points, this point here at -2, 0, would have reflected to +2, 0 over here in my green dot, but it's also doubled, bringing it over to here. Another point, this point here, I'm drawing it on the original graph of -1, 1, reflects to be +1, 1, but then it also doubles. Thank you for check for understanding number 3. Okay, I forgot the domain and range. I'm not going to forget again. So I'll just shift this graph over a little bit, and we'll write the domain and range over here. Domain. Domain is what x can be, the restrictions on x. For this question, notice that x can be anything less than -4 on the new graph. So we say x less than or equal to +4. In interval notation, the largest that x can be is 4, so that has a square bracket allocated to it, and it goes to the left infinitely forever, so that's -infinity. When you have a graph that continues, you draw a round bracket signifying continuous. Okay, move that up a bit. Now the range. The range is what y can be. What can y be in this question? Well, the graph starts as low as the x-axis, no further, and goes up to the left. So y is greater than or equal to 0. And in interval notation, small number on the left, big number on the right, it goes up infinitely, so that's the positive infinity, and it goes down to 0. It includes 0, so we put a square bracket beside it. Let's now check to see if we got the answer right. I will pull out the solution. Does it look like what we've done on the same grid? I know it's a little tough to see at home, but it looks perfect. Any questions on that? Well, hopefully there aren't. If there are, go on Edmodo and ask each other.